Welcome back, chemistry fans. Today we are going to do the percent composition, which is really actually a percent hydration lab. So let's jump right into it. What we have got on the table here is, what we have on the table here is a bunch of equipment so we can perform this task. About my hot plate is already piping warm hot. I have an evaporating dish. Hear a little sizzle, that's because I just rinsed it clean. I have a container that has copper sulfate in it. Copper sulfate is just some blue rocks, very bright blue, cobalt blue rocks. And then we have a mortar and pestle. We're going to grind that up. I've got my nice little hot mitt to protect myself. And then I have some utensils to try and move the chemicals from one location to the next. And then I've got my balance. And so I'll have to show you some of that, and we'll take this data here together. So what I'm going to do is first, I'm just going to take a scoopful of the blue powder or the blue rocks. I'm going to put them into my mortar and pestle, fill up my container. And then what I'm going to do is I'm just going to start grinding on this here. I'm going to start turning this blue rocks into a nice light blue, azure blue powder. And that's just going to create a higher surface area for us. So it makes the process of heating go by a little faster. So that's all I did there. So I'm going to take now my hot probably plate there. And what I'm evaporating dish, and I'm going to use my spatula, and I'm going to, I need to first get the mass of my object. So you can see that there now, what it weighs. And what I'm going to do is I'm going to tare it so it's not actually weighing the object. Then I'm going to add to it my powder. If I don't get all the powder out, that's okay. It's not a big deal. What I am going to do though is I'm going to spread it around so that it evenly heats up and it does it faster. Okay, so I'm going to write down what my weight is before, and I'll share that with you later. 1.71 grams. Now this material has water trapped inside of the crystals. So what we're going to do, we're going to put it up on the hot plate. You can actually see the hot plate, the contents inside of it. Time elapsed. That is actually going to start to evaporate and change colors. You can actually hear it when you're doing this lab. You can actually hear it starting to sizzle as some of the water is beginning to evaporate. So hopefully this will not take too long. What I am going to do is pause the video so that you're not having to sit here and wait as long. Okay, we are back live. And what you can see now is that my sample is changed colors. It has changed colors. It's actually almost starting to turn completely white. So in contrast from where it was as a light blue powder, you can see it's starting to have a little bit more of a green color to it, a little bit less of the blue. And in contrast to where it began, oh my gosh, you could see clearly that it has changed colors. And the rationale for that change is because it removed the water that is inside of each one of those molecules. So what we are going to do next is we are going to weigh this now, and we're going to find out how much it has lost in water weight. We're going to compare it to what we know the water weight's supposed to be. I'm going to let it cool for a second. Okay, now I am ready. I'm going to turn this back on. Unfortunately, when it turned off, it erased my value of my balance. So I do not know what it started out as. So I'm going to take this value and then I'm going to rinse it out and get the weight of just the crucible. So 58.04 is where it is right now. 58.04. Well, it's now gone down 58.00. Is it going to go lower? No, it's not. Okay, so that's my empty weight. So what I'm going to do is I'm going to get rid of all of that. And then I'm going to try and get rid of a little bit more of that added weight that was in there. I'm going to dry it off. And then I'm going to weigh it. So I know what the weight of just the evaporating dish is after that. So here we go. Tear that weight again, boom. So it was 58, now it is 56.87, 56.87. So if I subtract those two numbers, I would get 1.13 as my weight. That's how much it weighed without the water. All right, so I'm going to move this junk out of the way so that we can start now doing a little bit of the math associated with the problem. Okay, here we are. Let me bring you down. I'll put you in front of the camera so that we can see what we're trying to accomplish here. Okay, here we are. You know what? Let's do it this way. Let's do this differently. We're smart. We can do this. We're learning. Okay, so in this lab, what we started with, why did it stop? Let's try that again. Here we are. Okay, so in this lab, what we started with, the before weight. This has water. This has H2O in it. That is 1.71. The after we heated it, it has no water in it. It was 1.13. If I subtract those two numbers from one another, 58.58, that's how much water we lost right there. Those are the gram amounts of how much water we lost. So now I'm going to get a calculator out and I'm going to figure out, well, what is my percentage that I had lost from this experiment? So 0.58, because percent composition is part divided by whole. Or in this case, it is the H2O weight divided by the H2O plus copper sulfate weight. So in other words, it is the difference, it's the after, well, no, it's the water weight divided by the before weight. All right, so I've got 0.58 divided by 1.71. Divided by 1.71. And what we end up with is about 34%. That's pretty good, 34%. And I say that that's pretty good because if I do the math associated with the formula is CuSO4, 5 waters. And what you end up with is it's actually 36% water. Well, compared to the 34, that's not bad. So let's do a percent error on this. Wrong minus correct divided by correct. Or you could say correct minus wrong. It doesn't matter because it's absolute value. So I'm going to have 36 minus 34. Here, I'll even switch this so I'm writing it correctly. Correct minus wrong. Divided by 36. So I've got 2 over 36. And what I end up with is roughly 5.5% error. That's pretty doggone good for a very simple lab activity that we just did. All right, this is what I wanted you to try and accomplish while I was absent or while you were absent. So thank you very much for your time. And hopefully you now understand the process better. Bye.